Hey guys, real quick, I'm just going to help you figure out how to create the best fit window for some of these problems that have large numbers. A few people have been asking about this. So in this particular problem, there's another video that kind of explains a little more in depth. I'm going to focus mainly on getting the calculator set up correctly so that you can see the graph. So in this one, we're creating this profit function, which is revenue minus cost. So I'm going to go to my calculator here. My function should be, in this case, the revenue function was 490x, and we're going to subtract, I'll go up here and do it, 490x, and we're going to subtract away the cost function like this. Make sure you put it in parentheses. The other thing we can, of course, do is, since it's in parentheses, the better thing would be to drop the parentheses and we can just distribute the subtraction sign. So this is my profit function. Now, if you just look at this on the standard window, you're probably not going to see very much. So the question is, how do I get my window set so that I can definitely see everything? There are some ways you can do, like a zoom fit is kind of the down and dirty way to do it. It sometimes will work. It's not always great. So in that case, not such a great representation. So I'm going to go back to my zoom standard to go back to my 10 by 10. So what we can do here, the best place to start is to first take a look at your function and figure out where the vertical intercept and where the vertex is going to be. So for example, on this one, this is the C term right here, the negative 2360. So I know that's going to be my vertical intercept. So if I'm kind of thinking about what my graph is going to look like, I know that my vertical intercept is going to be down here at negative 2360. So that's kind of a good place to start. In terms of knowing how low I need to go in the window. The other thing I can do is I can try to figure out where my vertex is going to be. So let's see. I'm going to use my negative b over 2 times a formula to get the x value of the vertex. So in this case, let me just write my I'm going to write my formula over here. So it was 490 x minus 2360, and then minus 2.2 x squared. So in this case, my a term is going to be negative 2.2, and my b term in this case is 490, because that's the part that goes with just the x to the first power. So let's see, I'll go over here. I'm going to do negative 490 divided by 2 times negative 2.2. Okay, so that's my x value. My vertex is 111 approximately. So it's about 111. It's not quite. And then what I can do, here's a little shortcut. I can store this as x in my main screen, and now I can type this equation directly in. 490x minus 2360 minus 2.2 x squared. This is going to give me the y value. The y value is really high, 24,924. So I know that my vertex is like somewhere up here, and it's like, we'll say it's approximately 25,000, because we're just trying to get an estimate right now in terms of making my window. You can of course record this down and you'll know exactly where the vertex is, but just for getting the window, if we get somewhere around 25,000, that should catch it. So I know my parabola is going to look something, excuse my drawing. I'm not using a great mouse right now. It's going to look something like this. So whenever I go into my window, I can kind of use that to help me start, that I know my y minimum value. It needs to be at least 2360, so maybe I'll just go ahead and make it like negative 2500. And then my y maximum value, I'm going to go ahead and make it like 25,000. And let's just see where that gets us. Okay. Now the other thing is that the x value right here, where the vertex is up to 111. So if I can think about from here to here is 111, and then from, I can kind of think about doubling this to maybe like 222 to get where the where the parabola goes up and where it comes back down. So I'm going to go back into my window, and I'm going to take the y max. I'm going to make it like 222, and let's just see what that does. And there we go. So this is the 111, approximately 25,000 up to get the vertex right here. And then, like I said, I just figured out that, well, it's halfway up is about 111. So if I want to go all the way back down and catch the right-hand side of the vertex, I should probably double that and go out to 222. And there you go, right there. I got a nice full picture of my parabola. Okay, so you can kind of use this technique whenever you're trying to get the window set. I know it's kind of tricky if you're not really used to dealing with it, but look at the vertical intercept and then look at the vertex, because those are going to kind of give you good ideas of where your y value should be. And then if you look at the x value of the vertex, you can double that x value and make sure that you're at least going out that far in your x max or your x min values, so that you can make sure to catch like the left and right hand sides of the parabola. So there's not really necessarily a shortcut way to do it all the time, but that's like a good way to kind of figure it out. So hopefully that's helpful.